Yeah, so thank you very much, Andrea and Alberto, for just few words before moving to the use cases. So we had a brief overview about what is possible, what are the challenges in the fleet management, and what a Dave embedded system with ToloMEO can offer you to support these challenges and to face these challenges. Now, let's say we change a little bit the topic. So we see some real examples where ToloMEO and our competencies were applied in the last years. So I leave the stage to Alberto and Andrea again to sum up and propose you few use cases about our experience. Thank you.
Okay, thank you, Manuele. Let's start from the first use case. That is the Prometheus. Prometheus is an European project aiming to monitor the brain oxygenation of preterm babies to optimize the feeding of the baby, to optimize the brain oxygenation itself. So for this project, we design a custom hardware board for the medical environment. And we customize the board support package with the hardening feature provided by ToloMEO to ensure the cybersecurity of the system in compliance with the medical device regulation. We also integrate all the feature for the monitoring of the vulnerability of the system to provide prompt and to provide quickly the update of the system. Finally, we integrate the IoT and the fleet management solution of ToloMEO alongside with the OTA module to monitor all the devices in the field, to update them, and to collect information about the functionalities and the way the devices are working in the field. We also use some artificial intelligence algorithms that can run on the device. Finally, we develop for this project also the local UI, the dashboard that you see in this picture, to monitor all the parameters recorded by the sensor weared by the babies. And we also developed the cloud application where the doctor can collect and monitor more device in the hospital. This is a research project, so the aim is to provide a POC of the system, a working prototype that we will test in the real environment in the hospital with the real babies during the next year. Another use case of ToloMEO is for a robot mower that is a classical home automation device. And in this case, the customer has many thousands of devices in the field across the world. And for this project, the connectivity is very challenging. It is intermittent and with very low bandwidth. So we integrated the ToloMEO BSP with the hardening feature to improve the cybersecurity. of the device, and we also enable the vulnerability monitor module of the ToloMEO platform, and the BSP maintenance to provide updates and to respond to vulnerabilities that will be found in the field. Finally, we integrate the fleet manager to provide to our customer information about the device in the field, and we integrated the OTA modules on the cloud side and the edge side, mainly for the differential update, because in this context we have low bandwidth, so we have to provide very small, teeny updates that can be deployed around the world. Another use case is for UPS, industrial UPS. So we are talking about industrial automation, where we design a monitoring board for this device. Here, the cybersecurity requirements are very high, and they need the compliance with the ISA 62443, both for the hardware, the operating system, and the application layer. We use ToloMEO BSP with the hardening in the version compliant with the ISA 62443 standard. And based on this core component of the platform, we develop the application layer for the customer, also in compliance with the industrial cybersecurity regulation. Moreover, to guarantee the cybersecurity, we enable the vulnerability monitor and the BSP maintenance that allow us to provide updates to our customer to be integrated in their application updates for the device in the field.
Okay, we have two more use cases to show. Before diving into this use case you can see right now, let's take a quick flashback to say that Dave Embedded Systems started working in the field of AI at the edge back in 2020, when COVID-19 epidemic exploded. At that time, the first industrial system on chips for the mass market equipped with neural network accelerators started to appear. At that time, we developed a social distancing verification system based on the use of machine learning vision algorithms running on NXP i.MX 8M Plus system on chip. The skills we have acquired since enable us to support our clients in addressing issues related to the AI at the edge topic, like the one I am going to illustrate in the next slide. Recently, we received this prompt from a customer. Is it possible to detect how many people are in a room in order to automatically adjust air conditioning slash ventilation slash heating to optimal levels? Using the knowledge acquired, it is possible to consider creating an automated system then using inexpensive image sensor is able to count in real time and locally, i.e. no inference at the cloud, the number, layout, and physical characteristics of the people present in the room, and therefore act on the HVAC system. We exploited the knowledge we acquired previously, and so we implemented this proof of concept with the same system on chip I mentioned above. Thanks to the integration of an NPU, the algorithm is CPU offloaded And so most of the computation related to the neural network is performed by the hardware accelerator. The last use case refers to a sophisticated system that exploits the federated learning paradigm described by Alberto previously. In short, this paradigm means that edge devices, thanks to their local inference and model training capabilities, work together to improve the knowledge of the model they use. Cyclically, the new knowledge acquired by each edge device based on the data samples on which they perform inference is condensed by a central server, which then distributes a new, improved model to all the devices. We are going to migrate a real-world example exploiting federated learning to the ToloMEO platform, and it is related to smart endoscopes. This slide shows some information about this concrete example. Of course, we are in the biomedical field, and we are talking about specifically smart endoscopes. These devices are used by doctors to provide real-time support while performing exams on patients to identify potential pathologies of the gastroesophageal tract. The graph on the left shows how, in our test carried out with real data, the performance of the model used for inference in terms of accuracy improved over time, thanks to the sharing of newly acquired knowledge between the various endoscopes. For more details about this study, you can refer to the article linked at the bottom of the slide.